All right, algebra, we are still working in section 3.2. We're starting with example 6. If I look here at variable expressions, we read that the properties of rational exponents and radicals can also be applied to expressions involving variables. Because a variable can be positive, negative, or zero, sometimes absolute value is needed when simplifying a variable expression. So if we look, when n is odd, we know that something is going to stay negative. When n is even, we actually need the absolute value of it. Cool? Absolute value is not needed when all variables are assumed to be positive. Okay, assumed to be positive. Let's practice. So simplify the expression, assume all variables are, in fact, positive. If I see here, I have third root of 64 and y to the 6th. I can actually simplify 64 to 4 to the third power, and y squared as y to the 6th is y squared to the third power. If you remember, we've done it a few times now, y squared to the third power is the same as y to the 6th, right? So now, when I have third root of something to the third power, those cancel each other out because it's actually 3 over 3, which is 1, and y squared to the 3 over 3, which is y squared. So we're just going to write simply 4y squared. Okay, next one is very similar. 27 p to the third power q to the 12th power. I have 3 to the third power, p to the third power, and q to the 3 to the 4th power. Nope, that's backwards. I want the 3 to be on the outside. And all of this is to the third power. I can now distribute that power of a power inside, and I'll get 3 to the 3 over 3, p to the 3 over 3, and q to the 4 to the 3 over 3. So I have 3 times p times q to the 4th, right? Okay, still working on simplifying expressions and assuming all variables are positive. This is 1/4 power. So I can actually do m to the 4th over n to the 8th. The top, I'll change it in a minute. We're not going to do anything right now. But the denominator, I'm going to change that to n squared to the 4th power, because 2 times 4 is 8. Now if I take the 4th root of m to the 4th, I get m. The 4th root of n squared to the 4th, I get n squared. And this last one, 14 xy to the 3rd, 2x to the 3/4, z to the negative 6. Let's look at the coefficients first. I can take that as a 7. I can't read it anymore though. I have x to the 1st power minus 3/4. Because the base is x, the exponent on top is the 1, exponent on the bottom is the 3/4. Y to the 1/3 and z to the positive 6 if I bring it up to the numerator. So 1 minus 3/4 is 1/4. This one's going to stay. And z to the 6th. There's not much I can do with that one. All right, next example. Write variable expressions in simplest form. Assume all variables are positive. Okay, this is quite complicated, but I'm going to try to factor out perfect fifth powers. So I've got a 4, an a, I can say a to the 5th and a to the 3rd, because this right here would be a perfect 5th power, b to the 10th and b to the 4th, okay, perfect, and c to the 5th. So let me take out all of the things that are perfect 5th powers. A to the 5th, b to the 10th, and c to the 5th. And leave in everything that's not perfect. A to the 3rd, b to the 4th. I'm going to write that one more time. A to the 5th, I can't do anything. B squared to the 5th and c to the 5th. And then the next one stays. Just going to rewrite it. This gives me a final answer of, this gives me an A, this gives me a B squared, and this is a C. And then underneath the radical is 4A cubed B to the 4th. Not too bad, right? This is all underneath the radical. Cool. Okay, write the expression in simplest form. Assume all variables are positive. So we're going to try to make this denominator a perfect cube. I can't do anything with a y to the 8th, but I can do something with a y to the 9th, because that would be y 3 to the 3rd. If I take the 3rd root of that, I get y to the 3rd power, right? So let's see how I can make that happen. That's my goal right now, is to make that happen in the denominator. If I multiply the numerator and denominator by y, remember we multiply across the top and across the bottom, that means in the numerator I'd have xy, and in the denominator I add those exponents and I get to the 9th power. So here I have xy in the numerator and y to the 9th, which is y to the 3rd times 3, y to the 3rd to the 3rd, power of a power. So in the numerator, I'm stuck with this, and in the denominator, I have y to the 3rd power. That one's a bit tricky, okay? With some practice, you'll get it, but it is just a tad bit tricky. All right, example 8. It's our last type of example, and then we'll have a little bit more practice problems, but here's our last example. So perform the indicated operation. Assume all variables are positive. Remember, if we have the same radical, we can add what I call the coefficients. 1/5 plus 3/5, they're the same denominator, so that's actually 4/5 square root w. If you remember when we did this in the first 3.2 video, we can factor out the square root w and then add the fractions. And that's perfect. If that's the way you think, go for it. I usually just think of these as coefficients and I can add them up. Let's see, on part B, I have an xy to the 4th and an xy to the 4th. That means those are the same, so I can just do the math with the coefficients. 3 minus 8 is -5, and xy to the 4th does not change. Another example. Let's see, here I have 2z to the 5th, not 2z to the 5th, but that radical can change to 2 times 27, z squared, did I say to the 5th? Oh, I need to change that one too. 3rd root. 3rd root, can't do much with a 2, but I can make this one 3 to the third. So I can take out that 3. So 3z third root of 2z squared. I don't know why I'm still working in red. I can actually do something with that z to the 5th power now. Cubed root of 2z squared, z to the third. So because it's a cubed root and it's z to the third, I can take a z out. I forgot the 12 over here. 2z squared. Now I have 2z squared and 2z squared. I can do the math that it wants me to do. So 12z, cubed root of 2z squared, minus 3z, cubed root of 2z squared. That gives me 9 cubed root, 9z, cubed root of 2z squared. Notice that cubed root is in the radical, not a part of the z. Okay, let's practice a few. Simplify the expression. Again, I'm trying to get my numbers and my exponents to be, this one would be a perfect cube. So I can make that 27 a 3 to the third power, and that q to the third power to the third power, because once I have the third powers and it's a cubed root, I can go straight away to simplifying. It's almost like this cancels that and that. Cool. Same here. 5th root, I'm going to say that is x squared to the 5th, because 2 times 5 is 10, over 5th root y to the 5th. So I have the 5th root of something to the 5th power. It simplifies. 5th root, 5th power, y. Here, going back to where I did things simply, I can simplify that. 6 divided by 3 is 2. Now I'm going to take all of the same bases and just subtract the exponents. 1 minus 1/2. And I can't see it. Oops. And then I have 3/4 minus 3/2, to minus 1/2, sorry. 3/4 minus 1/2. Let's see what happens. I get 2. 1 minus 1/2 is 1/2. 3/4 minus 1/2 is 1/4. And if those fractions are what's holding you back, just go ahead and get your calculator out. Okay, no judging. All right, like on number 13, like I've said to a few people in the past, if there's no root here, we know that it's a 2. I will never write those 2's, but we need to know that. So let's simplify this. So I have square root, 3 squared, and then w squared. This will give me 4, right? 2 times 2 is 4. And plus that one is 5. That's a little crazy. Minus w squared, w. That's 3. Okay? Now notice, this is square root. So if these match, I can take out a 3. If these match, I can take out a w squared. And there's still a w left in there. Square root. So if these match, I can take out a w. I add it to this one, and I get a w squared on the outside. And I have a w on the inside. Now I have 3w squared minus w squared. And that gives me 2w squared, square root of w. Remember, there's a 1 here if there's no number. That one was tricky. Daily homework quiz. These are some extra ones if you'd like to practice. I'm just going to write down the answers. We have here 49. Here we have 5. These are great ones just to practice. 4th root of 3. A squared over 3b cubed. 4th root x cubed y squared. Y squared. These are the tricky ones, right? 1/2 a squared b. Length of the hypotenuse of a right triangle. If the legs x and 2x. If you remember, it's a squared plus b, oops, sorry, a squared plus b squared equals c squared, where that's our hypotenuse. So x squared plus 2x squared equals c squared. 5x squared equals c squared. Square root of both sides. C equals the x square roots of 5 if I simplify that. Okay, see if you can get that. Nice work. That's it. We're done.